by the time we're done here, I want you to be familiar with not necessarily how we measure distances, but just the units that people use to measure distances for astronomical things, right? So the first unit is an astronomical unit, and an astronomical unit, 1 AU, right, is the distance from the Earth to the Sun, right? There we go. Okay. And basically, the way we figured this out is sort of clever, right? We knew this thing. This is Kepler's third law, right? We knew this relationship, which means, and we knew the period. We knew the two periods. Like we knew how long it took Earth to go around the Sun, how long it took Mars to go around the Sun. People were very clever that way, right? But we knew neither one of these things, right? We didn't know the radius of Earth's orbit and the radius of Mars' orbit, right? And then the second thing we did was in 1672, they did a parallax, right, on Mars, right? Mars is an outer planet. In fact, it's the outer planet to us. When it's in opposition, it's actually quite close to us. The orbits are pretty close. It looks considerably and noticeably larger in the sky when it's in opposition because of its orbit, right? So opposition means it's like, our orbit, Mars's orbit, right? Here's us, here's Mars, right? It's a little bit closer when it's in opposition like that, right? And so what they had to do in 1672 was that they were, and I don't know if that's really where this is, right? But they observed Mars in Paris and they observed it in Cayenne at the same time. Now they did that, what they did basically was they used their cell phones and they called each other up and they say, okay, mark where it is now, right? Why do they have to do that? Why do they have to observe it at the same time? Why couldn't they just have, observe it in Paris and then paddle their boat across the ocean to Cayenne and observe?
Earth's rotation.
The Earth moves and Mars moves, doesn't it? In fact, the word planet means wanderer, yes? Planets were these objects that moved. The stars were fixed, or more or less fixed, right? In the night sky, they couldn't, the ancient observers couldn't see the stars move, right? You need a telescope. Some of the close ones actually do, okay? But the planets moved all over, right? And in fact, if you observed Mars now and you observed Mars in 10 minutes, you could, with a good enough telescope, see that it moves. How do you measure these angles? Do you have like a big protractor or something like that? I never understood this as a kid, right? As a student. Do they have a big protractor? Or is it that Mars, as seen from Paris, lines up with a distant star, and in Cayenne it lines up with a different distant star? Is that what it is? Yeah, that's what it is. The stars have been charted in the sky, their exact positions, since a long, long time ago. Okay, Tycho Brahe and all these guys, right? Okay, and so they know what these distant stars are, where they are in the sky, and so in Paris you see it against a different set of stars than you see it in Cayenne, right? This is exaggerated. It's not nearly this big. Now, let's go back to the other challenge. You have to observe it at the same time. How do you do that? Well, you have to have a clock, don't you? Yeah, you got to have your clock. You got to know how far over Paris or Cayenne is, right, on the globe, which means you've got to have a clock that you can take on a boat. This is tricky. Do pendulum clocks work on boats? No, they notably do not, right? So you have to have a modern chronograph, right, with not so modern like digital, right, but one of those ones with the little spinny wheels, right, on them for it to work, right? You also, by the way, need to know what time of day it is to know your longitude. Right? Latitude's easy. It's just the angle the sun makes in the sky at noon or something like that. You can figure it out. Longitude is you figure out at high noon, right? As you head west, it takes longer, doesn't it? Is it that right? Yeah. As you head west, it takes longer for the sun to get above you, right? Like say you take a clock from the East Coast, yes, and you head west across the United States. At noon, the sun starts to lag behind you, right? It's farther and farther to the east as you head across the United States, until by the time you get to the West Coast, what is it, like 3 hours, right? It's like 9 o'clock, and that locally, right? But you think it's noon, and it's like the sun's 3 hours from the zenith, right? So, modern navigation, you got to have a clock. You got to have a good clock, and that's what they had to have to measure this, right? So anyway, they figured this out. I got this thing. I thought this was great. The diagram of the opposition, and they talked about this, right? And this is Cassini, the guy of the rings around Saturn. There's a division called the Cassini division. He was the guy that did this, right? Anyway, short story is, once you know this distance, the Mars's radius minus Earth's radius, you have one equation. The other equation is this. You can solve that. That can be solved. And this is what an astronomical unit is, right? It's roughly 1.5 times 10 to the 8th kilometers, or if you prefer, 1.5 times 10 to the 11th meters, right? Things are so big that we're going to use a lot of kilometers. Remember, it's just a factor of 1,000, so scientific notation's our friend. And I think you have that, right? So that's our first concept, right? So how about a whiteboard? Crack out a whiteboard. I know. Say it again. If you find cool links that have cool information, that'd be cool too.
It's like a big chart of like the driving power and everything.
Yeah, maybe. Okay. I don't know. If you find links, just paste the link in there. And that's a big project, so don't stress out. I don't want you to, don't like relapse into your sickness. Can you guys bring a rag instead of using? I know. So the question is, how do you convert 4,500 million kilometers, which, by the way, you just do this. Right? How do you turn that into astronomical units without using your cell phone? You could do it with your cell phone, you know that. It is beautiful. They're all beautiful. I do.
Thank you.
Yeah. Yeah. Say it again. To get kilometers, you're going to use this number, right? You're basically going to divide this by this, right? Denied. You can do that with a text message too. Don't, but yeah, the 30, yeah. Nice letters. That's right. So you could probably escape from like handcuffs and stuff. Yeah, yeah. Yeah. Tengo una calculadora. Tengo una calculadora. Necesito. What did you say? Tu necesite? Necesitas? I haven't learned that yet. But I know how to say this. I'm learning Spanish and I know how to say buenos días and buenas tardes. And I know why.